Okay, question number 6. So question number 6 is from integration. Integration using 𝗏𝗏𝗃𝗵 rule. Okay. So you can see a figure. This is a shape given, and the part. This is not shape. Basically, this is a curve. Yeah, a curve is given. So they are modeling this curve as a river. Okay. At one particular place, the river is 15-meter wide. You can see the 15-meter wide has been represented by the separation of the x values from the origin till x equals to 15. Okay. The depth y meters of the river is measured at a point x meters from one side of the river. One side of the river. Okay. So at any point x, consider from that x, the width, sorry, the depth is measured by y values. What y values? The y values of this curve represents the width in meters. Okay. So figure 1 shows a plot of cross section of the river and the coordinate values x, y. Okay. So we need to use the trapezium rule with all the y values in figure 1 to estimate the cross sectional area of the river. So we need to use the trapezium rule. Okay. So for using the trapezium rule, at first consider the area of trapezium. What's the area of trapezium? We know the area of trapezium is half of A plus B times H, right? Okay. Where A and B are the two parallel sides of a trapezium, and H is the distance of separation between the two parallel sides of the trapezium. Okay. So in trapezium rule, since we will be dividing the area into small trapeziums. Like this is one trapezium, this is the next one, then again this one. These are all trapeziums, and you can see that the first one, it starts from 0, so it is basically you can consider a triangle since one of the parallel side is 0. Okay, so the first one, you can see this height, this depth basically. This depth is common between this trapezium and that trapezium. So when we will be adding the areas of the trapeziums, the formula that we can get from here, it is what? Half taken common from all of the areas of the trapezium. So half times what? H. H can be taken common because the the sorry, the separation, the distance of separation between the two parallel sides, it is constant. You see, from 0 to 3, from 3 to 6, always it is increasing by 3 meters. So H is 3 in this case. H is 3. Now the first height is 0. So 3 times what? We will put a second bracket there. The first is 0. First one is 0. Okay. And the second one is, the last one is also 0. So 0 plus 0. It's not required to be written, but just for explaining the concept of trapezium rule, I'm showing. So plus next is what? In If you are adding the areas, you can see in that area, this height will be considered once. And then again, when you will be considering this area, the area of the second trapezium, this height will be again getting considered. That's why we need to multiply 2 times the rest of the heights. What are there? 1.52, 1.52 plus what? 2.74, 2.74, then 3.12, then 3.08. That's it. This is the trapezium rule. Okay. So let's write it in the part of solution for part A. The area would be half of what I said. The separation is what? 3 times. Then first depth is 0 and the last depth is what? 0. And between them, what are the heights? 1.52, 2.74, 1.52 plus 2.74 plus what? 3.12, 3.12 plus 3.08. So 3.08. That's it. So the unit should be meter squared, the cross-sectional area. So the value is 1.52 plus 2.74 plus 3.12 plus 3.08 times 3 times half. So this is 15.69. We need to estimate. So in that case, we can consider the value up to 2 decimal place. Since you can see the values are given to 2 decimal place. Okay, 2 decimal place. So this is 15.69 meters squared. That's the answer. Okay. Next is part B. In part B, the water in the river is modeled as flowing at a constant speed, the constant speed of 1.5 meter per second across the whole of the cross section. Okay. So the speed is given. Fine. Use the model and the answer to part A. In part A, we got the area. Okay. To estimate the volume of water flowing through this section of the river each minute. So we need to find out the volume of water. The volume of water that is flowing to this section of the river in 1 minute. That is in 60 seconds. Okay. So the speed is given. So if you see, the unit for speed is meter per second, right? So with the speed, if you multiply the time, total time, how much time is there? 60 seconds. So if you multiply 60 with 1.5, you are getting the length of the what? Of the river. The length of the river that has been flowed by the volume of fluid, volume of water. So volume is what? Length times the cross-sectional area. Okay. So that's why we are finding the length at first by multiplying the speed with the time, total time. So volume would be V equals to 1.5 times 60. We got the length, and with the length multiply the volume, multiply the cross section. 15.69. You will get the unit is what? Meter cube. So volume of water flowing through this section of the river each minute. Okay, giving you answer in meter cube. Okay. In 1 minute, how much will be flowing through? Okay. So the value 15.69 times 60 times 1.5. This is 1412.1. They wanted how many significant figures? 2 significant figures. So the actual value is 1412.1 meter cube. So to two decimal place, we can write 1400. 1400 meter cube. Two significant figures. Two as that's it. That is part B. Two significant figures. Okay. Now, just an important question. Like, assuming the model state giving a reason for your answer, whether your answer for part B is an overestimate or an underestimate. Whether is it an overestimate or an underestimate. Okay. Of the true volume of water flowing through this section of the river each minute. Okay, fine. So whether it is an overestimate or an underestimate, how can you understand? It's just by watching the figure, the diagram given. If you see the diagram, you can see that if I let me show you using a straight line. Wait there. I'm skipping. Okay, this is the straight line you can see. Should be more straight. Okay, like that. So you can see that the curve, it is getting curved towards the x-axis. So when you will be estimating using trapezium rule, your estimated values, since it's getting curved towards the x-axis, towards this direction, so when you will be estimating, the trapeziums will get out of the curve. The trapeziums will get out of the curves. So since the trapeziums are getting out of the curves, that means the area that you will be estimating using the trapezium rule, it will be just an overestimate. Okay. Because since the curve, the line, the graph, you can see it is getting curved towards the x-axis. So that's why when you will be considering the trapeziums area will get out of the curve a bit. That's why it will be an overestimate. Okay, so the reason is that we can say for part C, it will be an what? An overestimate, since the curve is approaching towards the x-axis. That's why. Towards the x-axis. That's it. This is why it will be an overestimate. That's it.